In this video, we will see how we can source and simultaneously measure DC voltages. Now for this, we are going to need to use the Alice meter source tool. The icon to that should be on your desktop, and it says Alice M1K meter source. And the reason we are going to need this tool is because we not only need to measure voltages, but we are also going to see how we can source voltages and the ability to change that supply voltage. So let's go through these slides and talk about a circuit. So first, we are going to try to build this circuit on the proto board. There are three resistors, R1 of value 1 kilo ohm, R2 of value 1.5 kilo ohm, and R3 of value 6.8 kilo ohm. I've placed these resistors such that R2 and R3 are in parallel to each other, and the combination of R2 and R3 is in series with R1. And as you can see on my proto board, I already have that connected. So I have R1, which is of value 1 kilo ohm, and I know it is 1 kilo ohm because the color code, the rings are brown, black, red, and then followed by gold. So that's my R1. And I've connected that to a parallel combination of R2 and R3. One of them is R2, the other is R3. For example, the top one is brown, blue, red, gold, and that's 1.5K. And the bottom one is blue, gray, red, gold. That's my 6.8K resistor. And they are both sharing the ends. So the two ends of R2 and R3 are placed on the same column of 5 points. So they are connected in parallel that way. Now, the first thing that I'm going to talk about is how do I make the connections between the M1K board to the proto board such that I can source voltages and also be able to measure voltages using the two channels, channel A and channel B. Now this is a little bit different from what we have been seeing so far. With the voltmeter, you were only measuring DC voltages, and for your supply, you were using 5 volts and 2.5 volts. Now what if we need to source 1 volt or 2 volts or 3 volts? We should be able to change those DC supply voltages. And we can do that using the Alice meter source tool that we are going to use right now. We just need to be careful about the mode we choose. How do we select split IO or don't split IO? That's what is going to be critical. So just off the bat, I'm going to talk about the split IO. We see this particular switch here. Now, if the switch is not connected the way it is shown, then it is in the split IO mode, meaning the source unit is disconnected from the measure unit of the voltmeter. The voltmeter is disconnected from the two sources here. That's called split input and output. Now, if we don't do that, then that toggle switch will be connected, meaning CH input and CH in input will be connected together. So whatever you plug in on one of them, that's what you will measure using the voltmeter. So let's go through this and build the circuit first. So for R1, which is of value 1 kilo ohm, I have two pins on two things connected to that on the left end of R1. One is A in. A in is being used here to just measure voltages. And I'm indicating that with a orange box. So what I'm going to do is, just to stay consistent in terms of the color of the wires, I'm going to use an orange wire, plug that into A in, which is the topmost pin here on M1K, and then I'm going to connect that to the one end of my 1 kilo ohm resistor. And I've done that. I've connected that to the same column of 5 points. Now another thing that I need on that same node, on that same junction, is channel A, and I'm using red color for that as indicated over here. So I'm going to do channel A, which is the second from the top pin on M1K board, and I'm going to connect that also to the same place as the orange wire. So I've made all the connections over here. AN is now connected to R1, is also connected to CHA. All of them are on the same column of 5 points. So I'm using 3 of them, so I still have 2 empty slots left. Now, those 3 points through R1 are connected to the parallel combination of R2 and R3. Right now, I already have R2 and R3 set up. All I would need to do is the place where R1 meets R2 and R3 also has channel B or B in. And I'm using this only to measure the voltage, so we can use the CHB pin or B in pin. Either one will work because we are not going to split IO for channel B. So let me just use channel B here, which is second from the bottom. You guys could use B in as well. It doesn't really matter because we don't split IO in this case, meaning this will be connected. So CH input here will be connected to CH input here for channel B. So I've made the connection with the blue wire to the same place where R1 meets the parallel combination of R2 and R3 to the M1K board channel B. Now the other end, the last connection that I need to make is of the ground. So for ground, I'm going to use black. I can use one of the grounds here. I will just use one of them and then connect that to the rightmost end of R2 and R3. So I hope now you see the 3 components being used, R1, R2, R3, how they have been set up on the proto board, and 1, 2, 3, 4 connections coming from the M1K board to the proto board. Orange, A in, ability to measure voltage. Channel A in red, ability to source a voltage. Channel B or B in, we are just using that to measure voltage at that point. Ground, that is going to work as our reference node. So after making all these connections, let us see if we can use the meter source tool to scan some DC voltages on channel A. While we are changing the voltage of channel A, we are also going to be measuring the same voltage on A in, the meter. So source, meter. For channel B is just functioning as a meter. Channel A, of course, we need to split IO because we are independently sourcing and measuring at the same time, at the same point, at the same pin. So we are going to need to set channel A in split IO mode. We don't need to do that for channel B because we are just using that to measure. Again, the DC voltages that are being measured are with respect to ground. Now let's go to the last slide here. Over here, we are going to set up this experiment to determine the voltage drop across each element. So voltage drop across R1 and voltage drop across R2 and R3 should be the same because R2 and R3 are the same. Voltage drop across either resistor should be the same value. So what we are going to do is we are going to change channel A voltage. And as we are changing that voltage, we will measure what is the voltage at this pin using A in. For that, we would have to put channel A in the split IO mode, and I'll show you in just a minute how to do that. We are also going to measure on channel B the voltage at that point. By using those voltages on channel A and channel B, we can measure voltage across R1, which would simply be channel A voltage, which is A in, measured through A in, minus channel B voltage. So CAV minus CBV, just as you did earlier. And then for R2 and R3, that is going to be channel B voltage minus 0. So that's just channel B voltage. And once we have all these voltages, we can use Ohm's law to find out the current through R1, R2, and R3. So let us try to launch M1K M1K meter source tool and see how we can make those selections. So I'm going to double click on this icon here that should launch the Alice meter source tool. And I'm going to place that right here. Right now it is in the stop mode. It is not running. And in this, you see 4 things. channel A meter, channel B meter, channel A source, channel B source. As for the sources, channel A is off right now, channel B is also off right now. Now, what do I need? I need channel A to be on and be supplying my voltages. So what I'm going to do is I'm going to put my channel A in the split IO mode. I'm going to check this box first. This is important to do. But for channel B, I'm not going to use that as a source, so I can leave that off. Later, I will be turning on channel A when I'm ready to make the measurements. When I do that, whatever I have connected to the pin A in, that is what I'm going to measure in this box for channel A meter. Whatever I have connected to either one of these pins, channel B or B in, that is the voltage that I'm going to measure over here in this box, channel B meter. So let's do this. Let's turn on channel A and let's run this meter. So as I run this meter, it is showing very, very small values of voltage for channel A and channel B. The reason for that is even though channel A is on and I have done the split IO, I have not provided any voltage on channel A. So I need to increase this value here. And the easy way to increase this value here is if you take your mouse, hover it on that, and then use your wheel to just scroll up, it keeps increasing. And then scroll down, it will keep decreasing. In fact, you can even go 0.01 and then go up and down. Then you will, to make some small increments or decrements. So what I'll do is this. I will try to go to 0.5 and see what happens. I'm going to go up 1, 2, 3, 4, 5. I have set channel A voltage as 0.5. So obviously, because channel A and A in are the same point, on channel A meter, I should measure whatever I'm sourcing using channel A. So that's 0.5. That is inconsistent with what I have set it to. Now channel B meter right now is measuring 0.275 volts. So that's the voltage at that point right there with respect to ground. Now, what do we know from this? We know that if we had provided 0.5 volts of input using channel A, then we would have 0.5 volts at that point, and we would have 0.275 volts at that point. Let's go even up further. And at each of these increments, you can calculate voltage across R1 and voltage across R2, R3. Those should be the same, of course, the last two. And you can make all the current measurements, just as we talked about earlier. So let me increase this voltage to 1 volt. So I've gone up to 1 volt. My channel A meter is measuring 1 volt and channel B meter is measuring 0.55 volts. And I can similarly keep doing this. I can keep going up to 2 volts. And at that point, I have 2 volts for channel A meter and 1.099 for channel B meter, and so on. You can go as high as 5 volts for channel A voltage. The key thing here is that I have selected split IO mode for channel A, which is what is allowing me to independently source a voltage and measure a voltage on channel A, because I have split IO, meaning I have disconnected it the way it is shown. So I'm independently able to use this voltage source to give me a voltage, and on a different pin, A in this case, I'm able to use the voltmeter. So I hope that was helpful discussion. And as did the voltmeter, even here, it gives you channel A minus channel B voltage directly. So 0.9 volts, that is essentially the voltage drop across R1. The voltage drop across R2 and R3 are going to be 1.099 volts for input being 2 volts. The input is provided at that pin right there. All right, so I hope you find this helpful and are careful about how you set the split IO mode. I'm going to stop the video right here. Before that, I can stop this.